Good morning to one and all. Dear students, last class we completed relation and function chapter. Now today's class we must discuss with a complex number. Okay, it's a very simple concept and very basic concept you are studied in your high school level. That continuation part it is complex number. Okay, so first of all I will discuss with you people. This chapter contain 9 marks for your annual examination point of view. Okay, now first of all I will write here complex numbers and quadratic equations. Dear students, this chapter contain 9 marks for your annual examination point of view. 1 marks contain one question, 2 marks question contain one question, and 3 marks question will contain two questions. So 1 marks one question, 2 marks one question, 3 marks two means 6 plus 2 7 8 and this one 9. So totally 9 marks chapter it is. So in this chapter there is no 5 marks, there is no 6 marks, there is no 4 marks. So only 1 marks, 2 marks, 3 marks. Okay na? Right. So this is your annual examination point of view I discussed. Now let us we will go to basic concept because of see how the complex number will use and why it is required to use the complex number concept and why we will study complex number. Okay, let us we will discuss. Okay, right. Now dear students, so first of all I will write here very basic concept, natural number. Dear students, natural number already you are studied. It is a used for counting. It is natural number is nothing but what used for counting, and so starts from 1 2 3 up to infinity numbers we can write. Okay, these type of numbers we call it as a natural number, and always this one indicated capital letter n. It is always the natural number will be indicated. Natural number means capital N. It is the indication symbol. It is capital N. Okay. Next, for example, we will write in symbolically, that is n equal to starts from 1 comma 2 comma 3 comma 4 comma dash dash dash. Okay. Next, second one, whole number. Whole number. Dear students, very simple concepts. Whole number is nothing but if you added 0 in a natural number. If you added 0 in a natural number, then only we call it as a whole number it is. And it is denoted by capital letter W. And it is denoted by what? Capital letter W it is. Okay. Next, capital letter W. And in generally we will write capital W equal to, we will start with the 0, 1, 2, 3, dash dash dash. So this one we call it as what? Whole number. And the next one is, we will go to integer. Dear students, integer is nothing but it contains all type of numbers, positive numbers, negative numbers, and including 0. So that form we call it as what? Integer, and it is denoted by capital letter I. So I will write here integer. Integer numbers indicated capital letter I it is. So that is symbolically we will write I equal to dash 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 minus 3 comma minus 2 comma minus 1 comma 0 comma 1 comma 2 comma 3 comma dash dash dash. So these type of numbers we call it as what? integers. Okay now. Next we go to rational numbers. Now just I want to remove this part. Rational numbers. Okay. Listen here. Students, a rational number, the numbers which can be expressed in the form of what? P by Q, where P and Q are integers and Q is not equal to 0. This condition is satisfied means those numbers we call it as what? Rational numbers. Okay now. Always you can take any type of numbers, but we must express in the form of P by Q only. And especially rational numbers we will indicate at the capital letter Q it is. We will indicate it what? Capital letter Q. So Q equal to, in general form we will write Q equal to x such that x equal to P by Q, where P comma Q is belongs to capital I and Q is not equal to 0. So this is the general form of what a rational number it is. This is the general form of a rational number it is. Okay now. Right. Next, irrational number. Irrational numbers. So irrational number means, so here these type of numbers we can express in a decimal form and square root form and pi, etc. So these type of form means which cannot be expressed in P by Q. Okay, x equal to not x not equal to P by Q. We can express what in the form of a decimal form or in uh, symbolically form we can express. Okay, and it is denoted by capital letter T. It is capital letter T. Example, we will write 0.0005, 0.00089 pi cube root of 5 root of 7, etc. So these are all are irrational numbers. These all are irrational numbers. So here we will express in decimal form, square root, cube root, pi. So these are the example of irrational numbers. So finally we will saying it is not equal to P by Q. It is okay. Right. Next, real numbers. Real numbers. Okay, dear students, I think you are studied in your 10th real numbers chapter. So real number is nothing but what? Yes, exactly correct. It is the real number. It is a combination of rational and irrational number. So combination of rational and irrational numbers. Okay now. So that type of numbers we call it as what a real number it is. Okay. Now I will write here symbolically. It is always denoted by R. It is. It is always denoted by capital R, and symbolically I will write here R equal to Q plus T. R equal to Q plus T. It is nothing but what? Q is a rational number and T is a irrational number. The combination of rational and irrational numbers we call it as a real number it is. Okay, and it is denoted by capital letter I. Sorry, R. Okay, don't get confusion. Real number and relations. Okay, so commonly in a relation we will write R, but here the real symbol of real number is R. It is okay. Now these all the concepts you are studied in your high school level. Just I recalled one time. Okay, just I recalled one time. But dear students, the next concept is we will seeing. Now I will remove this concept. So everything you are studied in your high school level, these all are basic concepts. Okay. Now, dear students, commonly I will discuss with you people. Example, x square minus 9 equal to 0, x square minus 25 equal to 0, x square minus 49 equal to 0. Okay, dear students, can we find the x value here in these three problems? Yes, of course, we can solve the problem. Okay, how to solve this one? See, x square minus 9 is there, means how to write this? Minus 9 comes to this side, you will get what? 9, and x square equal to 9 is there, so finally you will get plus or minus 3. You will get what? X value plus or minus 3. Similarly, next one, x square minus 25 is there. X square equal to 25. Next, x equal to plus or minus 5. X equal to plus or minus 5. Next, x square equal to this minus 49 comes to this side. We get x square equal to 49. Implies x equal to, see, 49 is the square root is here, square is there, this square comes to this side, you get the square root. So square root of 49 plus or minus 7 is there. Now dear students, x square minus 9 is there, means x square minus 9 equal to 0, means you will get what? X value plus or minus 3. X square minus 25 equal to 0, means you will get what? X equal to plus or minus 5. X square minus 49 equal to 0, means you will get what? X value plus or minus 7. Okay, is it correct na? Yes, 100% it is correct. But my question is when the square root of negative numbers, for example, now already you have studied this concept. Now my question is, x square plus 9 equal to 0, x square plus 25 equal to 0, x square plus 49 equal to 0, means how to solve? Some students are saying, sir, similarly you can solve previously whatever you solved na, same similarly you can solve anta ಹೇಳ್ಬೋದು ಕೆಲವರು. But here check it, all of you, x square plus 9 equal to 0 is there. Simplify this one. X square equal to this plus 9 comes to this side, you will get minus 9, and x equal to, you will get what? X square equal to, sorry, x equal to this square comes to this side, square root of minus 9. Dear students, square root of a negative real number is there. Only we studied what? Square root of 9. Square root of 9 we can write directly plus or minus 3. Next, square root of 25 you can write the plus or minus 5. Square root of 49 you can write a plus or minus 7. But in this condition, square root of negative number is there. Square root of negative number is there. See, next question, x square plus 25 is there. So x square plus 25 equal to 0 is there. Now I will write here x equal to square root of minus 25. Next, x equal to square root of minus 49. Now dear students, you check it, all of you, each and every x value contain square root of a negative real number. Square root of negative real number. So in this time we can't solve the x value. In this condition we can't solve the x value. For that purpose, the mathematician Leonard Euler was the first mathematician to introduce the symbol I. So I is the nothing but what? Iota. I is the nothing but what? Iota. This is a Greek word. It is I is a imaginary number. It is, we consider what? Imaginary number, imaginary unit, imaginary quantity. We consider I. Okay. This I will be indicating square root of negative value, square root of a real number. Square root of a negative real number, the symbol we will taking what? I is nothing but what? Imaginary number. So the mathematician Euler was introduced the symbol. So dear students, so why we are using the complex number concept means the complex number, it's a very useful for our real number and imaginary part it contains. So that's why we will use it. Okay, let it be. First of all, we will, okay, dear students, Leonard Euler, the first mathematician, introduced the symbol I. I is nothing but iota. So here, square root of I value, the property of I value, the property of I value is square root of a minus one. I equal to what? Square root of a minus one. So the value of square root of minus one, we can say what? I is the nothing but what? Imaginary number. We will consider what? Imaginary number. Okay now. For example, I square is there means we can write directly minus one. Here I square is there means apply both sides square on both sides, then you will get I square equal to square will get cancel. You will get what? Minus one. Get what? Minus 1 it is. Okay, okay, so this is uh, basic concept of it is. Now in a complex number, how we will use the imaginary and real part. Okay, okay, now first of all I will write some problems or some examples. Here square root of minus 3, or otherwise the square root of minus 5, square root of minus 9, square root of minus 25. So in this condition, listen here, all of you, square root of a minus 3 is that means we can write separately square root of 3 into square root of minus 1. Square root of 3 into square root of a minus 1 separately. Now I will write square root of 3, I will write as it is. Now only we study square root of a minus 1. Square root of minus 1 is nothing but what? Imaginary number. Imaginary means iota. I it is I value or property square root of minus 1. So we can write directly root 3 I. Root 3 I it is. Okay. Next, square root of minus 5 is there. Square root of minus 5 we can write square root of 5 into square root of minus 1 equal to root 5 into I it is. Root 5 into I it is. Next, similarly, we can write square root of 9 into square root of minus 1. We can write separately. We can write separately and we can write in the form imaginary number. The form of photo imaginary number form. Okay. So each and every problems, these four problems is that these all are called as imaginary numbers. Okay. Now square root of minus 9, root 9 into root square root minus 1 equal to plus or minus 3 I it is. Next, similarly here also root 25 into square root of minus 1 equal to plus or minus 5 I it is. Plus or minus 5 I it is. So these are the example of iota it is. These are the example of what iota it is. Okay. Now, okay. Now some students still getting confusion about I. So for that purpose, I will write the uh, imaginary number. How we will find the imaginary number? Okay, I will write here imaginary imaginary number. Imaginary number is nothing but the square root of a negative real number. The square root of a negative real number, real numbers is called imaginary imaginary number. Imaginary number, over or we call it as another name, imaginary unit over or imaginary quantity, imaginary quantity. Okay, so imaginary number we call it as a imaginary quantity also, or imaginary unit. Okay, right. Okay, dear students, next we will go to another concept, or otherwise if you want to example means I will write the examples. Example, if you want to example means I will write here square root of 3, square root of minus 5, square root of minus 7, square root of minus 3 by 2, etc, etc, etc. Okay, and here don't get confusion. So 3, 5, 7, these are all are real number only, but negative is there. So square root of negative numbers, the square root of negative numbers we call it as imaginary number, not a 3, 5 is an imaginary, not a imaginary. These are real numbers, 3, 5, 7, 3 by 2. These are all are real number only. But we are using what? Square root of a negative numbers. Na? So for that purpose, this totally term we call it as what? Imaginary numbers. So these are the example. Okay, now next we go to integral powers of iota. Integrals powers of iota. So in quadratic equation only one question will covered in your annual examination point of view. So that is only direct we must find the factors with the imaginary part. So only 3 marks will cover. We will go to after completion of complex number chapter. Okay, now let us we will discuss integral powers of iota. Integrals powers of iota. Integral powers of iota. Okay, now let us we will discuss for example for example we have I equal to square root of minus 1. We have what? I equal to square root of minus 1. Then I want to I square value. Then I want to I square value. How to write that one? So I square equal to, how to write this one? Square root of minus 1 whole square. So square root get cancelled. You will get what? Minus 1. So which implies I square equal to minus 1. So directly we can write in problems. So he will asking directly I to the power of 5, I to the power of 10, I to the power of 20. So this type of concept we can write directly. Okay, now so but before we solve the I to the power of 100,000, so that type of problem, before solve the problems, we can know the, we can perfect the these I to the power of 1, I to I square, I cube, I to the power of 4, I to the power of 5, I to the power of 6, at least minimum I to the power of 4. If you perfect means you can solve the remaining whatever the power is there, we can solve. Okay, now I to the power of, so here I equal to square root of minus 1, it is I square is there. So I value square root minus 1. So square is then a whole square, it is square get cancelled, minus 1 means I square value minus 1 will come. Next I cube means how to solve. So I will write here I square separately into I separately. I split this one. So I square value already we know what is I square value, minus 1 into I value root of minus 1 it is. So you can write directly I only, minus 1 into I minus I it is. minus 1 into I minus I it is. So this is your value. So finally your value I cube is nothing but what? Minus I it is. I cube is nothing but what? Minus I it is. Next, I to the power of 4. I to the power of 4, how to write? I square into I square equal to I square value minus 1 into I square value again minus 1. So minus 1 into minus 1 plus 1 it is. So 1 it is. So therefore I to the power of 4 is nothing but what? 1 it is. I to the power of 4 is nothing but what? 1 it is. So I value square root of minus 1, I square value minus 1, I cube value minus I to the power of 4 value 1. If you perfect these 4 values means you can solve any type of powers. Okay, you can solve any type of higher power. Okay, now in generally I will write in in generally for any for any integer n, I will write it directly here. Suppose the I to the power of, suppose I will write I to the power of n, I to the power of 4n, I to the power of 4n equal to 1 it is. Listen here all of you, this is general form it is. Why we are using these general form is a very essential. Suppose more than 5, more than 5 means up to, you can take any type of numbers, I to the power of 1000, I to the power of 2000, I to the power of 10,000. So you can take any type of numbers, so we can solve with the help of these general form. We can solve with the help of these general form. For that purpose I will write here. Okay, now I to the power of 4n equal to what? 1 it is. So next, I to the power of 4n plus 1, 4n plus 1, listen here all of you, I to the power of 4n is nothing but what? 1 it is, correct? Next, I to the power of 4n plus 1 is there. 4n plus 1 means I will write here I to the power of 4n into I to the power of 1. I to the power of 1 is nothing but I only. So I to the power of 1 value, I to the power of 4n value 1 it is. So we will write 1 into I. So your answer is I. Your answer is what? I it is. So I to the power of 4n equal to 1. I to the power of 4n plus 1 equal to what? I it is. Next, I to the power of 4n plus 2. I to the power of 4n plus 2. I to the power of 4n plus. So how to write this one? So we will write I to the power of 4n into I square. I to the power of 4n into I square it is. Next, I to the power of 4n value always 1 it is, into I square value minus 1 it is. So then what about I to the power of 4n plus 2 value? Minus 1 it is. I to the power of 4n plus 2 value minus 1 it is. So this is your answer. This is your answer. Next, I to the power of 4n plus 3. I to the power of 4n plus 3. The value will become what? I to the power of 4n into I cube. I to the power of 4n value 1 into I cube value. Now only I wrote I cube value minus I it is. Multiply here minus I. So totally your answer will come minus I it is. I to the power of 4n plus 3 value is minus I. Okay. If you want to separately means you can write it in separately one more time. How? I to the power of 4n equal to 1. Okay, next, I to the power of 4n plus 1 equal to here, see, check it, what is the value? I. Next, I to the power of 4n plus 2 equal to I minus 1 it is, minus 1. Okay, next, I to the power of 4n plus 3 equal to minus I it is, minus I. So these are the values of general form of powers of iota. Okay, powers of iota. If you perfect these first 1 2 4 and general form of I to the power of 4 into I to the power of 4n plus 3 means you can solve any type of problems, any type of problems. Okay, right. Okay, now. Okay. So now we will discuss some problems about these concepts. Okay, we will solve some problems about these concepts. Okay, now I will remove this one, or otherwise I will write here only examples. Examples. How these problems we are using. Okay, how the concept, these type of concept will use. Okay, now listen here, all of you. So first of all, I will take. I want to find the value of I to the power of 100. I want to find the value of I to the power of 100. Second one, I to the power of 2000, and third one is I to the power of 2020. So next, fourth one, I to the power of 580. Okay, or otherwise you can take a 103. 103. Okay, now. So you can take any one. Just I taken here another one problem. I will take I to the power of 85. 85. Okay. Oh. These are the examples. Okay. If you want to more problems about these concepts, you can refer to okay NCRT textbook, or otherwise Bosco, GK Ranganath, S Chand publication is there. So just the knowledge purposely, just I taken 5 problems. If you perfect means you can solve any type of problems. Okay, and some concept is there. After completion of those concept, we go to solve these type of problems. Okay, now I to the power of 100 is there. See, we know only I value, I square, I cube, I to the power of 4. Correct? Yes. So these 4 we know the value. And next, another in general form, we know I to the power of 4n. We know I to the power of 4n plus 1. We know I to the power of 4n plus 2. We know I to the power of 4n plus 3 value. Okay. With the help of these concepts, with the help of these concepts, we can solve the first 5 problems. Okay. Now, see, listen here. I to the power of 100 is there. I to the power of 100 means we will write, we will solve with the help of this formula. We will solve with the help of this formula. Okay, check it here. For how much 100 it is? Can you simplify this one? For how much 100? 425 is 425 is 100 it is. So can we write I to the power of 4 into bracket 4 into bracket 25 4 is 100 na? Yes. So 4 into 25. 25. Dear students, listen here. Here I to the power of 100 I taken like this in general form. With the help of general form, I can solve this one. Okay. So I to the power of 4n. N is nothing but what here? 25u. Because I want to solve I to the power of 100. So for that purpose, I split I to the power of 4 in form. So I to the power of 4 into, you can take any type of n value. We are not bothered about that concept. But we must focus 4 is there or not. I to the power of 4 of n. Yes. The value will come what? 1 it is. The value will come what? 1 it is. Okay. Next. Second one. I to the power of 2000 is given. I to the power of 2000. Now I will write I 4 of. See, 4 how much? 2000. 4 500 or 500 for the 2000 value will come. So now I will write I of 4 I to the power 4 into 500. I to the power 4 into 500. So we will write 5 4s are 20. So remain 0 is there. So 2000. So I to the power 4 n. We consider what this is what n it is. So for that purpose again the value will come what 1 only. Okay. Next. I to the power of 2020 I taken means I to the power of 2020 it is. So again I will split like this. I to the power of 4 into 5 not 4 I to the power of 4 into 504. I to the power of 4 into 504. The value will come what? So again we consider this is n it is. So your value will come what? 1 it is. Okay. Next. Next. See, I to the power of 103 is given. I to the power of 103 can be write I to the power of 4 into 4 how much 100? 4 25 is 4 25 is 100. Okay, extra plus 3 is then so I will write here I to the power of 4 25 is nearest value. We will go to nearest value. Okay, I to the power of 4 into 25 will become what? 100 plus 3 plus 3, then only you will get what? 1 or 3, then only you will get what? 1 or 3. Now you check it, the students already here formula is there. I to the power of 4 into n means 25 it is. I to the power of 4 of 25 plus 3 is there, plus 3 is there, so your value will come what? Minus I. You write directly minus I. You must write directly minus I it is. Okay. Next, I to the power of 85 is there. I to the power of 85 you can be write I to the power of 4 into 20 or no, 21. I to the power of 4 into 21 means you will get what? 84. Okay, plus 1 is there na? You write plus 1. Plus 1. I to the power of 4 of 21 plus 1 it is. So totally the value will become what? The value will become I to the power of 4 of 21 plus 1. So 84 plus 1 85 it is. So 4n plus 1. I to the power of 4n plus 1. The value will come what? I. Right. I. That's right. I it is. So we can solve like this, these type of problems. And similarly, so many type of problem is there, but we must use the general form of powers of iota. With the help of these, we can solve. Okay, right. Now one more formula is there. So that is I to the power of one more formula is there. You can use I to the power of minus 1, 1 by I, or otherwise minus I it is. So this is also very important it is. This is also very important. I to the power of minus 1 we can write 1 by I, or otherwise you can write minus I. Okay, this is also one of the important formula. So you must add with these formulas. Okay, right. Now so these all are what we studied imaginary related concept. We studied what imaginary related concept. But now let us we will discuss a complex number. Why we are using complex number? Imaginary number is we know. Okay, imaginary number means the square root of a negative real numbers. The square root of a negative real numbers we call it as what? Imaginary numbers, or imaginary quantity, or imaginary units. Okay na? Then why it is the use of a complex number? This concept let us will see. Okay, now I will remove this. Okay, just I will write the definition only. Today we will discuss definition only. Complex number generally I will explain. See, complex number means uh, given two real numbers a and b are two real numbers, and which can be expressed in the form of what? A plus ib, and it is denoted by capital letter z it is. Okay, a and b are two real numbers. A and b are two real numbers which can be expressed in the form a plus ib. Okay, and and it is denoted by capital letter z it is. It is denoted by capital letter z. So that is z equal to a plus ib. Z equal to a plus ib. Okay. Okay, dear students, this is your definition of a complex number. So a and b are two real numbers. A and b are two real numbers which can be expressed in the form a plus ib, and it is denoted by capital letter Z. Z equal to a plus ib. So this is Z. It is okay, na? Z equal to a plus ib. So if you express in this form means we can call it as a complex number. Okay, so here a and b are real number only, but here two part is there. So a is the real part, ib we call it as what, imaginary part, because of I is there na. So for this purpose we call it as what, imaginary number, imaginary part it is, we call it as imaginary part. Okay, in a complex number it contains a real number and imaginary number. Okay, it contains real and imaginary number. So for the combination of both real and imaginary, we call it as what, a complex number. Okay, we call it as what, a complex number. So whatever we studied, natural number, whole number, integers, rational numbers, irrational numbers, real numbers. Okay, so just we will studying up to, you are studied in your high school level up to real number, but here imaginary number we will studying, and the combination real and imaginary is called as a complex number. So in this chapter, so with the help of these concept we will studying modulus, conjugation of a complex number, modulus of a complex number, and some graph also we will study. Okay, so these concept we will studying for the coming classes. Okay, so today is enough. Thank you.